Welcome to the introductory lecture for the brain class. This is the basis for developing osteopathic treatment of the brain. So there's a deliberate choice not to call it craniosacral because we have to build also the craniosacral work from scratch. So we have to see what is actually viable and where we can start. So we first look at the brain from a point of view of neuroscience and the point of view of osteopathy. So these are the two elements. Of course, we need to study neuroscience, and we have to be very clear what we are expecting in osteopathy by treating the brain. So these are our two pillars. And because we are focusing on osteopathy and we are osteopaths, we also have to be quite clear of what are our ideas and expectations. So what is our goal in treatment? So why do we treat a brain? How are we treating a brain? And how do we study a brain? So is it only neuroscience, or do we also have a way of studying the brain? These are the three basic questions we should answer before we come up with any solutions. In all of the organs, in all of the tissues, we always use the same approach. That's basically the basic scientific approach to develop something new when you don't know yet what are you getting yourself into. We always start with perception because we are manual therapists. We treat manually. It's always about what can we palpate? What is the perceptual field of an osteopathic approach to the brain? This is always the most important part before we get into other concepts. And the first concept we get into, that's because we work clinically. It's the concept of activity. We did that with all the other tissues, also with the organs. It's about states of activity because this allows us to connect what we feel to a theory of health and disease, and also then to make decisions in treatment. So what should we treat is then based on what state of activity it is. And it's an interesting discussion within neuroscience, actually, how to measure states of activity in the organ. And the neutral state is not the arrested state. So there's very interesting discussions. And then the third part is always because we like to work holistically. It's how these activities and how these functions of the brain are embodied, and is that something we can feel, see, work with? This is always the approach we take. So to be a little more specific, perception, what we call the manual, the palpable qualities. So we still talk about qualities. That's the language from the 18th century, from Locke, from Goethe, from Kant. In the neuroscience, sometimes they talk about qualias, but it's because they talk about stuff like color perception and sound perception. But we still stick to the word qualities. That's what you can feel. It's the qualities of palpation and perception. And this for us is usually volume, form, movement, position, all these things we worked through already with other tissues and organs. And from what we feel, we bring it into an idea of regulated states of activity. This is the physiological theory we have. We have over probably the last 100 years since stress physiology and immunology. So every organ has different states of activity. And only if we understand and can feel these states, then we can make clinical decisions. Clinical decisions was always like what to treat, why to treat, and how to treat. So we need a clinical interpretation of these palpable qualities. And the best theory right now we have is from physiology and pathophysiology, and that's connected to states of activity. And of course, again, the highest crown in our field is always working with the embodied activity of the organ. So what is the embodiment of the brain? Is it expressed somewhere? Is it expressed in the skull? Is it expressed all over the body? Is it expressed in thinking? Can we feel thinking? Is it expressed in emotions? Or what is the holistic embodiment of the brain? And is that something we can pick up? Is it more the personality of the person? Is it how they operate, how they perceive, how they act? So these are all wonderful and very interesting questions if it comes to the embodiment of the brain. And then the question is it our field? Is it our scope of practice? So the problem of all osteopathic approaches until now, all what we would call either cranial sacral work or biodynamic cranial sacral work, they all have one major problem. It's they don't start with perception. Yeah, they start often with concepts. Even Sutherland, yeah, who was one of the first people who developed this kind of work, he started with a concept. Yeah? It was this vision or this idea that the cranium is like a breathing mechanism. That's already a concept. It's absolutely not true. The brain is not a breathing mechanism, and it's so that's already, if you start with a concept, it's already a problem. So, but you can correct concepts with perception, yeah. So that's important. But this is what we definitely avoid. Yeah, we don't start with concepts. We start with perception. So the other problem of all of osteopathic approaches had until now is they think about function, yeah? And in physiology, we think about activity. So the functions of the brain are very multiple, millions of different functions. And if this is actually our field, that is highly unlikely. Yeah? The function of a liver, the physiological function of the kidney, this is unbelievable complex and unbelievable minute and cellular. So there's no actual reason why we should be interacting with it. It's very difficult to understand for physiologists. And so what we usually work with is the activity. So the activity of the brain and not its function. Yeah, so this is, at least you should start with the activity because that's connected to the next question. And that's another big problem with all the osteopathic approaches on the cranium. They focus on motion, and this is kind of basically this bias coming from the somatic dysfunction, that motion is so important. It's not important in the brain. And if there's motion, it's anyway deformation. So there's no motion in the sense of like a joint motion. And if you focus on motion, you lose the tissue. So in a normal scientific university-based approach, you would start by looking at the tissue. Yeah? You would start by developing perception, and then you would try to kind of put your perception in the first conceptual idea about activities before you end up with function. So these three steps are always in the beginning. If they are not executed correctly, or they are not executed at all in most osteopathic approaches to the cranial sacral field, they're baseless. They have no foundation in reality, because reality is tissue, is activity, and it's our ability to perceive and to interact with activity and tissue. And it might sound strange for some of you who have osteopathic education, but this was not done, not from Sutherland and not from everyone who followed. They always start with concept, they think about function, and they slip very easily into motion. Even the biodynamic community, and in the end, they think about motion. Okay, so we look at the tissue of the organ brain. It has nerve cells, it has liquids, it has fascia, it has a lot of clear cells, up to 60% are clear cells. We look at its activity and we ask ourselves, how can we perceive the activity? And then we have a real problem. So this is our real problem. We had the same problem with any other tissue, with the organs, that our approach and the body's or the organs' approach are not the same. So our approach is we palpate from outside in. There's no other way. We're coming from the outside. So regarding the brain, we will go in contact with the container and then with the organ. So it's very different compared to the way the organs are organized, because the brain's approach is that it's actually inside out, So the body is organized from the inside out. So the brain is active, and the brain actually developed before there was the container. And since there's the organ and the container, there's a constant interaction. You cannot separate them. It's like with the lung and the ribs. So there is no lungs without the ribs, and there are no ribs without the lungs. So it would look totally different. It would feel different. Everything would be different. So in the cranium, there's no cranium without the bones and the fascia. And there's no bones and fascia of the cranium if there wouldn't be the brain. So they're always working together. only the way, we organize our perception, and the organs organizes its own life and its own embodiment, is totally the opposite. So that doesn't have to mean it's a total contradiction, but we just have to be aware of it, that we're coming from outside when we're trying to get through the container to the inside, but the organ is basically going the other way. Yeah, we could also say it's a wonderful image because we can meet in the middle. Yeah, the organ is expressing itself inside out, and we are trying to connect with the organ from outside in. And yeah, some of the people that I found really helpful thinking about these questions, and it's also a little introduction into the history of neuroscience. So whenever you get into the field, a new field, I can only encourage you to do things, study the history and study the methods, because it's very confusing. And every scientist knows that the people who are not in the field, they don't study methods and they don't study the history. So Heinz von Förster is a very important person in the history of brain science and neuroscience. And he's from Austria. He moved, I think, after the Second World War straight to America. He was famous for a lot of things. I will say a few little things about him. But why I'm using him here now is because he asked the question, what do you need to understand the brain? And his answer is, you need a brain. And that's a unique answer, because you don't need a liver to understand a liver. You don't have to be a jellyfish to understand a jellyfish. So it's a little bit different. So only brains can interact with brains. And this is going to be very important for every question about a therapeutic approach in osteopathy. He's famous because he's kind of the person who coined the word cybernetics. Yeah, I think after 45 he went to America, and he was one of the first people who organized conferences about cybernetics. But he's also one of the founders of a school that's called School of Constructivism. And when I was studying sociology and social anthropology in the 80s and 80s, this was kind of one of the things, I mean, you were tortured with, but it's wonderful, yeah. Constructivism is a wonderful field, and one of the first books we had to read was The Social Construction of Reality. And so you can learn a lot from constructivists, because they are really interesting people. Often they're really funny. They have funny examples. It's just only part of the world. Yeah? It's not all construction, but you need to understand, and also the new parts, the new way of thinking about the brain, and all the new research is very much focusing on the brain as a constructive organ. So this is going to be very interesting that after 70 years, Heinz von Förster's idea are coming back. And so he said, I need a brain to understand the brain. He also was very much focusing on the observer. He said a few things about that. He will come up again and again in the series of lectures. So because of his constructivist ideas, he also said what we are doing is we are observing the observer. Yeah? So when we do brain research, we're observing the observer, the brain being the observer. When we treat the brain, we kind of observing the observer with our hands, but we're also observing us because we're interacting with the observer. Then you have suddenly two observers. You have the brain, and we as therapists are ourselves brain. Yeah? So it's an overlap. Yeah? So this is when you connect to someone else's brain, you connect to their observer, and with your observer and your hands. Yeah? And in his approach, that's why he calls it second order cybernetics. Yeah, I'll say a little bit about it soon. The other person is already included because you're observing the observer. So it's obviously you're not alone there. You're always in relationship. Yeah. That's one of the newer things in neuroscience. Yeah, they would always point to the fact that the brain is an organ of relationship. Yeah? There would not be a brain if we would not be in relationship. Yeah? And the relationship is to the rest of the body and to the outside world. So he had an ethical imperative, and this is interesting also for us. Everything that is said by an observer. So this is the old mantra of constructivism. Yeah? That's not only what he said. Yeah? So, but in constructivism, it's clear if you say something, you're the observer. You're constructing the reality. It doesn't mean it's not real. It just means that there's a difference between your construction and maybe some of the parts of the reality. But then he added, as that this is now further, everything that is said to an observer, out of respect of the constructions, the self-constructions and the construction of the reality of the other person. You also have to be clear, you understand if you connect to someone else, you're also connecting to someone who's also constructing reality. So two people connecting who are both observers, but they're also both constructors of reality. So this is important because it's the only way probably we can treat the brain. Okay, so the brain in neuroscience, we will think about the brain in osteopathy and the brain in neuroscience. So this is kind of a summary of what I said before with a little showing the launch pad for the next step. So the brain in neuroscience has two major big fields. It's always evolutionary biology. So there's no chance to understand current neuroscience if you're not into evolutionary biology, because a lot what we know and don't know has to do with research on evolution. For example, the idea of a triune brain, of the reptile brain in us, this was debunked in the 70s already through evolutionary biology research. So there's no triune brain or no reptile brain in humans. We know that since the 70s. So evolutionary research, evolutionary biology is very important. And one of their statements is also very important. The brain is made for action. This is, of course, a sentence because for a long time, brain research was kind of doing computer research. So they used the brain as a paradigm for the computer, and then they also used the computer as a paradigm for the brain. And there was a lot about perception and classification and storage of information. And then the neuroscientists said, no, this is not true. The brain is made for action. It's not mainly there to perceive things. So action also includes perception, of course, but the brain is made to do something with the outer world, and it's not only there to store information. So this is a very important shift that was made in the 80s. There's a very interesting book. It's called Being There. I'm not sure if I remember the author. Andy Clark, Being There. They did a lot of research at MIT in Boston. They were comparing the paradigms of computers and brains, and they had to realize that computers don't really work if they use this model, and also the brains don't work like this. So an important shift in the 80s, and now it's there everywhere. And the other big part of brain research is about neurobiology of spirit and soul. It's about emotions, about consciousness. So this is kind of the two ends. There's a lot in the middle, but this is definitely things that we would have to study. And I gave you a few photos down there. I will say something on the right. Again, it's von Förster. On the left, it's an important person. It's Edelman. And about the other two people, I will say something. And remember, we need to understand the field. If we want to develop osteopathy out of science, we have to understand the field, and we have to really understand the field. And that means the methods and the history. Every scientist knows that other scientists who are not reading the method part of a study, they're not scientists. Just that if you haven't heard that, if you're a scientist in your field, the first thing you do if you have a new study, you read the methods, not the results, not the beginning, not whatever. You look at the methods, because the study is only as good as the methods are. And if the methods are good, it's good. If the methods are bullshit, then it's bullshit. So this is very easy. So please, we have the same problem with embryology. We have 70 years of embryology and osteopathy, and people basically didn't understand the basics. We need to get either into the field or take your hands off. And into the field means you understand the methods and you understand the history of the field. So these are two new current people. I picked two because they're quite famous. Michael Graziano is also Italian American, and he has this little animal. He has a talent. He's a ventriloquist, and he lets that little ape talk. And his field is basically social attention schema, the brain as a social organ, the development of consciousness. Just that you have an idea. These people are out there. They're amazing. They're brilliant, and they're doing a lot of research, and they're trying to find the activity of consciousness and awareness in the brain. And then the other one, she's kind of a superstar by now. Yeah, that happened over the last 10 years. She wrote a book that was called How Emotions Are Made. She's brilliant. She might be getting a Nobel Prize. I don't know if there's a Nobel Prize for science, for neuroscience, but maybe for physiology. But she's actually brilliant. She has a lab in the States. So you will hear a lot from her also if we talk about neurology and neuroscience for osteopathy. That was her teacher. He was one of the developers. Gerald Edelman, he got a Nobel Prize for, I think, in medicine or physiology for his research on immune globulins in the late 60s, 70s. He was then one of the founders of a field that is now called neuroscience. That was founded in the 70s and 80s. And he's also based in Boston. He's I think he's dead now, but he was one of the major researchers, and he's a brilliant mind. And Feldman Barrett Lisa Feldman Barrett it was one of his students. And for example, he developed a concept that is very interesting and not well understood. It's called the concept of not degeneration, but degeneracy. Yeah. So whenever you have extra time, check it out. I will talk about it later in the class. So let's go back to our problem, because these people can really help, yeah, because they give us hints and ideas, and then we have to go back to the way we investigate, because there's an osteopathic way to do research on the brain, but then we have to understand the quality of the organs and we have to understand as much as we can from this research. But it has to be always done in this way, because this is from perception to understanding. So we palpate the container. This is now we know it's an organ within container, and we start with a container and we go from the container to the contained, that is the organ. The word encephalon actually means that it's encapsulated, that it has a container. It's contained, it's embedded in a bony and fascia and liquid container. And it's important, because it's the same everywhere. The container and the contained are in constant interaction. Yeah? You don't have a chance to separate them. Whenever you feel the container, the influence of the contained is already included. Whenever you feel the brain, the fact that it's in a container is already included. You cannot separate them. Then in constant interaction, mechanically, and sometimes also through other ways. If you look from the inside, the brain expresses its activity in the somatic container. Yeah? So the main activity of the brain is electric and electromagnetic, and then there's metabolic activity, and there's vascular activity. And this activity, of course, because always it is in a container, it is already expressing itself in the container. So there will be some kind of a somatic expression of the brain activity in the container. And the container is the first connection when we do palpation. Yeah? So when you palpate from the container, then you already are connected to the brain activity. The big question is, how can we understand it, and is it clinically relevant? Okay, and then the last thing, it always has to do with embodiment. Yeah? So we always look for how are all these things working? Yeah? Because we know the language of the container and the contained. And this leads to an understanding of embodied function. But it's very important to always start from the relationship of the container and the contained. We did that with the vascular organs. We did that with the hollow organs. We're doing this with all organs and tissues, from the language of container and contained, or whatever the language is. We look how it is embodied and how is it in relationship. In relationship always means in relationship to yourself, oneself, and the outside world. Okay, so we have basically two qualities now. Now I'm narrowing it down, more and more down, like in a funnel. I'm getting more and more into the osteopathic field. Yeah? So we have a language of the container and contained. We know that very well from the gut and other organs. It has two parts. It puts the emphasis on relationships and on embodiment. Yeah? So the brain expresses its activity in mechanics, because it's a mechanical expression we feel. Yeah? So there's other activities, but in the end, what we feel is not electricity or something else. We feel mechanics. And that is a relationship. Yeah, the container uncontained is always in a relationship. And then it's also a part of the embodiment process. Yeah, so the brain is an organ of relationship and connectedness. So it's also expressing the person's inner and connection to the inner and outer world. Yeah? How are you dealing with your inner world and how are you dealing with your outer world? Yeah? So the brain expresses a much bigger thing, a much what we then call holistic or embodied. There are different words for it, yeah? But basically it says, yeah, it's expressing your relationship to the world. Yeah? So the small intestines was the organ of where you have this immediate, yeah, physiological, substantial relationship to the outside world. The alveoli, you have that relationship to the O2 CO2 quality of the outside world. Yeah, so these are also organs of relationship, the alveoli, the mucosa. But here it's an organ that is basically also expressing your connectedness and your relationship to the inner and the outer world. Yeah, so this is a very complex process, even more complex than in the alveoli and in the mucosa. It was pretty complex in the mucosa. It was pretty simple in the alveoli. But here it's much, much, much more complex because it might be expressing your whole personality, your whole tendency to deal with your inner and your outer world. Yeah. So bringing it even more down, going with the funnel one even step closer. When we talked about container and contained, we're dealing with the biomechanics of volume and form. Yeah. So this is our model because that's the model in physiology and psychodynamics. So the biomechanics of container and contained is always about stability and dynamics. You need a stable container, a more or less stable container, and that container can develop dynamics. If it comes to the brain as the organ also of thinking and perceiving, you need a stable container, you need a stable apparatus, we will say later, for thinking, and you need the ideas, and you need the dynamic of moving ideas. So it's going to be very interesting to look at the brain and its activity along these lines. Yeah? It's about form and volume. Yeah? So again, the brain is about form and volume. How much volume changes there is, it's very different to other organs, to the liver and other organs, but there's a minimal volume changes due to the liquids, and there's minimal changes of form. Yeah? If they're palpable or not, that's the question. But at least this is the systematic way to look at it. Yeah? So what is the form? Is the form in deforming? So there would be a motion we would call deformation. We would pick up in elasticity. And are there volume changes we would also pick up? And then we look for motion and rhythm. But again, remind yourself, this is not motion in terms of joint motion, because this is deformation. It's the deformation motion and the rhythm of the deformation. And this is usually called motility. And also Sutherland called it motility. Yeah, it was just a little strange that he didn't say where he got that term from. But in Sutherland's lists 1 to 5 of describing the activity of the cranial sacral rhythm, there's one point, I think it's number 5, that is actually the brain's motility, but he doesn't explain where he got that term from. And I found deep in some library, I think in Boston, I found a book from 1932. And there was a long article about the glia cells of the brain and they having motility. So there was research in the 1930s on the glia cells, yeah, not on the neural cells, that used the term motility, because that was not used a lot in that time, and often it was more used with the gut system. I found only a very few articles at that time, and this one was in a book that was from, I think, 1932. I could check it, and they talked about motility. And I think this is one of the things I would definitely offer to do very different than the tradition. If you use new terms, please tell us where they're from and who used them how. Because it's kind of weird that we have to do this research. Now, this term motility was very much uncommon at the time, and it had to be defined what you mean and where you got it from. Because he kind of hinted that it had to do with embryology, and that is definitely not what it's about. Yeah? So the only thing what it's about is that in embryology you develop form, and motility is kind of is using the form, but everything is using every force from the outside is using the form. The form is an invitation for all the forces. So of course, if there's motility, it will use the form, and of course the form develops in embryology, but it doesn't come from embryology. That's a very important distinction. Yeah. So yeah, we can talk. We can use the term motility, but I would rather not in the brain until we actually understand if there's motility. Motility means the activity is in the organ, and the source, the motor for the activity is in the organ. And it's not so clear if there's an intrinsic force in the neuron cells. If there's an intrinsic activity and creating motion in the glia cells, that's possible. In the vascular cells, definitely. So it's not clear where the motility is coming from. So we have to, at least until then, kind of be careful to talk about the motility of the brain. So yeah, this is kind of the typical osteopathic discussion all the time. Stability dynamics, form and volume, yeah, they're connected. Yeah? If there's a volume change, there's a form change because nothing is symmetrical. You're looking for emotion, but the motion is deformation. And if there's an organ that has a rhythm, of course, it's interesting to have a rhythm. We never use rhythms for diagnosis. This is after 100 years of trying in cranial osteopathy. Let's get rid of this. It's kind of embarrassing to have 10 different systems with 5 different rhythms, and this doesn't make sense. It's one organ. There has to be one description. And if we're not able to come up with a consistent description, we cannot use rhythm. There's a rhythm, we don't know what it means, and we don't know, and so until we don't know what it means, there's no point of making it the frequency higher or the amplitude higher or lower. It doesn't make sense. So if we know what the rhythm means, then we can say, okay, bring it down, bring it up, get more amplitude. Yeah? But as long as we don't understand why there's a rhythm and what it means clinically, there's no point of doing anything with it. So, big question mark. Yeah? There are many ideas, and we'll definitely talk about them, but I will not give them away now. But we'll have to go a little bit around the corner. So, what is the embodiment and embeddedness of the organ brain? Yeah? So, because we talked about container contained, yeah, this is still within the limits of what we understand, the physiology. We can go back to the cells. What is the quality of the cells, the mechanical? How do they express themselves? Is it possible to feel it? Is there expansion, compression? Is there torsion? So is there something we know from science we can look for? Is there something we feel? We might look in science for an explanation. So this is all done, and we can also go deeper. I mean, this is all what we should do. It's not done yet, but this is all what we do in the ACO-School for modern osteopathy. And then the next step would be to ask this question: what is the embodiment of the brain? Yeah? So how can we feel it? How can we talk about it? Because this is when you connect, yeah? You as a brain, we as a brain connect with another brain, something is happening there. It's an organ of relationship. It's embodying maybe your experience, your biography, your whatever, yeah, whatever you think it's embodying, and it's embedded. Yeah? It's embedded in a physical sense because it's embedded in the cranial fault. It has a bony embeddedness, and there's liquid like around a lot of other organs. And it's embedded because it's nourished by all the information from the outside. Yeah? The brain would not exist if it's not in contact with the outside world. So it's as an organ embedded in the outside world as much as the lungs are. No? The lungs are basically organs that are pushing out, like the small intestines with the mucosa. They're always looking for connection. So the alveoli, the mucosa, these are our organs where you can actually see how much we are connected to the outside world, and they only have a function in this connection. Yeah? So on this level, the brain is also embedded in the outside world. And the question is that something we can feel? Yeah? Is there a quality to different kinds of embeddedness and in relationship to the outside world? So to do this, yeah, something we have to do before, we have to clear the field, yeah, and not our field, the neuroscience field. And this is much easier than like 10, 20 years ago. There's definitely an old neuroscience and a new neuroscience. The new is not new from yesterday. It's there for the last 30 years, since the mid 80s. So it's already like 40 years, but it's very clear. Yeah. that we don't have a triune brain and the limbic system. That's clear for whatever 40 years. Some people still talk about it. It's okay. The triune brain is not okay. It doesn't exist. So in humans, there's no reptile brain, and the limbic system was supposed to be built around the reptile brain. So it's just not a system. Yeah. So you have all the stuff that used to build the limbic system. The new researchers will not talk about a limbic system because it's not a system, because it's not organized like a system. It's also because there are no centers for emotion. Yeah. So the old neurology was talking about centers, areas where everything had a center. Fear had a center, language had a center. This is not true. So we are not talking about this like now. So also the difference between emotions and reason, they're real, but they're not in the brain. You don't find areas for emotions and you don't find areas for reason. This just doesn't exist. So there's a lot of new ideas how to describe it. The brain is not organized for classification, so it's not a system to represent the world, to classify the world. This whole idea of the brain being kind of a computer where you store information about the outside world, that's just not true, because we see the brain does other things, like it does prediction. I will talk about the new neurology, new neuroscience in a second, and also this idea that there's a difference between the brain and the body. So this whole dichotomy, so this duality. Of course, the body and the brain are connected, and they're also one. The brain is part of the body, and the brain only exists because of the body. So the idea that you can take the brain out of the body as like a computer and put it somewhere else, this just has nothing to do with reality. And then the major issue nowadays, also because a lot of people in trauma therapy still believe that the brain is reconstructing reality. This is not the case. Yeah? So the new, let's go backwards. Yeah? The new neuroscience would say and would prove that the brain is constructing. The brain is not reconstructing. Yeah? There's no original model. There's nothing inherent in the brain. Emotions are not built in the brain, and that's also why there's no limbic system and no triune brain. There are no primitive emotions built in the brain. Emotions are constructed, yeah. Concepts are constructed. The brain is a constructive organ. It doesn't reconstruct, it constructs something, and emotions and concepts. It's embodied, yeah, because it's in the body. You cannot expect to understand the brain and to work with the brain if you don't understand that it's part of the body. It's always in connection. It's not only there to perceive, it's actually doing something very different. It does prediction. It's top down. It means the brain is permanently sending signals to the periphery, what it predicts in terms of, this is what I expect from this situation, from this reality. So I go out of the door and I predict that it's this, and this, and this, and this. So it's rainy, it's this. And if the reality is close to the prediction, the brain says, okay, this is it. If the reality is very different, so the brain always sends out a prediction. It's not a neutral agent who only receives information. No, the brain does predictive activity, so it puts out predictions and then it checks how different the reality is from the prediction. So this is a very different activity. And it's built for action and relationships. Yeah, so this is very clear that the brain has a very clear evolutionary purpose. It's built to act, to behave, and to be in relationships. So these are the new fields, and they're very interesting, because they're actually helping us. Yeah, the old neuroscience was, besides that it was kind of boring for someone like, for example, like me, who was very interested in thinking and other processes in the brain, and they could never explain thinking. It was just too complex. Yeah? So the whole idea of centers and areas and classification and representation, this is kind of a bureaucratic competency. This is bureaucratic activity. So if you're a bureaucrat, you cannot think. Yeah? So if you want to really understand how a brain is thinking and what it means to think, then the old neuroscience was basically crap. It didn't help at all. And the new neurosciences is not really explaining thinking, but it's at least working with models that are much closer to thinking. So just in one view, old and new. Yeah. So the old one is reconstructive. The new one is constructive. There's inherent things. No, we are building them. There's We are perceptive, yes, but we are not neutrally perceptive. We are predictive. It's not about classifying things and representing the world. It's the concepts. We're building concepts. We're building categories. So it's very different. Yeah? So that also means we can actually talk about embodied cognition. This is actually a term used in science, embodied cognition. So we have an embodied brain, and this is for us. It's definitely an invitation. Because if the brain is embodying its own experience, yeah, so what is the experience of the brain? This is kind of what we need because that's what we feel. What is the experience of the brain? So if it's really embodying and not only electrically communicating, it does much more. So if the brain is actually embodying its own experience, so it has an experience, this might be basically electromagnetic and also hormones and other things, but it's already embodying its own experience. And this is why we can feel it, because we cannot feel with our hands electromagnetic fields. We feel the effect of it. We cannot feel circulation and stuff. We feel embodied activity. And this is our chance because the brain is doing it itself. So new neuroscience and osteopathy, this is a deal. Yeah? So this could work. Yeah? So, but we have to start to combine it. Yeah? So get the different fields together. This would be wonderful. This would be and this is what we do in the School for Modern Osteopathy. So, just to wrap up, I have two more things: brain in new neuroscience and the brain in osteopathy. This is kind of the summary. Yeah. So, how does the new neuroscience look at the brain? Yeah, just as a summary, it's an organ of relationship, an organ in connectedness. It has electromagnetic activity. It's about polarizations. Yeah, the whole neural system is about polarization. It has electric and vascular pulsation. So it's interesting? Is that something we feel? We have to look at the cells and the networks, network activity, connectiveness. These are the newer words in neuroscience because they don't look at individual nerves. They look at the connectivity. The brain is about connectivity. And the functions are sensory motor. When we do sensory motor development, this is very important because this is in relationship to the brain being sensory motor. There's no separation of sensory motor. That's also why the sensory motor development of children is not separate. Definitely not. There are sensory motor areas, but this doesn't mean that the whole thing is sensory or motor. It's always sensory motor. There's regulation of all different processes in the brain. There's the perception action. Again, here also, there's not sensory or motor. There's not perception or action. It's always together, but it's a highly active organ for producing action. And in action is always perception. Very important, the quality of language in humans. This makes us unique. This is very difficult to do without brains. So whoever says you have a brain in your gut, try to talk with your gut. That's why this guy down there on the right with his ape, he's using the ventriloquist, so he talks with his gut. Basically, he talks through the animal. It's not a real animal, yes, but being a ventriloquist, he can use it. So. And again, we always are interested in the relationship of thinking, feeling, and acting. This was our question with the gut, with other tissues. What is the relationship of thinking, feeling, acting? And in the gut, the acting is digesting, the feeling is the sensitivity of the mucosa, and on and on. So these are the things we're looking into it. So in neuroscience, of course, evolutionary biology is big, so it's important. And there's a few special things in the brain. It has a lot of variability and variation. We'll come back to it, but these terms are important if we go deeper into neuroscience. So again, as a summary, brain in modern osteopathy, that's what we do. We always look at architecture. It's kind of the form of an organ. The architecture of the lung is the form of the lung, the inner architecture, the outer architecture. And then we look at that form and architecture and activity. That is the dynamic activity, the stability, the rhythm. So there's form dynamics, there's form stability, there's architecture, there's activity, and often the activity is rhythmical. So these are our interests. And then there's embodiment. That's kind of how the brain is expressing the experience of the organ, of the body and the person. So this is another question. Is it also expressing the relationship to the world? So this would be a really big issue if we could palpate that. So thank you for your interest and for your attention. I know this is a little bit tough in the beginning. That's why you can listen to it more and more. But this is the basic. We'll develop each of these parts. We'll go deeper and deeper into all those things. But just go through this again and again, because this is the basics of developing a kind of work with the brain that is solid and based in science and based in perception, based in tissue, based in activity, not made up, not fantasy, not conceptual. But this is really important, because we don't want to fall into the trap of the last 100 years. Yeah? We don't start with activity, we don't start with function, we don't start with movement without understanding what it means. So we really build it up from scratch. It might take a little while, but at least in the second and third semester, you will know where things are heading towards. Thanks for your interest and for your attention.